Hello everyone. This class is the first class of after the new year, and next week we will have the final exam. The time is from 9:10 a.m. At this classroom, and the sitting plan will be posted later. The exam regulations are the same as that of the midterm. The exam is by paper and pencil, closed book, and calculators are not allowed. And the scope of the final exam contains materials covered between November 22nd to January 3rd. And yesterday I updated the results of assignment 4. And one common mistake is that some students forget to initialize variables. And if you forget to initialize variables, your program might produce correct outputs in your computer. But if you try to test your program on a different computer, then the outputs of your program might not be correct. And you can take a look at this video if you are not how to properly initialize variables. And I also updated the results of assignment 5. And one common mistake about assignment 5 is that assignment 5 is to design a leaderboard system. And this system does not record items that are not in the leaderboard. And this means this system has no memory. For example, suppose we have entered one item, and this item is not added to the leaderboard. Then this item is discarded and will not be used in the future. This means this system has no memory. And you can try some test example. For example, for this example, if your system has memory, then the outputs of sample 6 will be wrong if your system has memory. In the previous lecture, we have learned what is a constructor, and we haven't finished yet, so we will continue the first part. And the constructor is a special member function. This function has the same name as the class, and this member function cannot return a value, not even void. So for this example, day of year is the constructor, and this function has the same name as the class, and this member function has no return data type. So before the function name, there is no return, there is no data type, not even void. So before the constructor, because this member function has no return data types. This is different to the output function. Output is a member function, and this function also has no return data. But this function output, the return data type of this function is void. And the constructor is invoked when we create create an object. So in this example, when we create data 1, then a corresponding constructor is called. So when we create this object data 1, and you check the definition of day of year, then you will find the corresponding constructor with 2 inputs will be called. And even though constructor is a member function, but we cannot call constructors like other member function. So we cannot use .day of year to invoke the constructor. This is illegal. The purpose of a constructor is to initialize member data. So for this example, we initialize a month and a day, and the month and day are member data of the class. For this constructor has 2 inputs, month value and the day value. And the day value is assigned to the member variable month, and the day value is assigned to the member variable day. And the C++ provides another method, and this method is called initialization section to initialize member data. The syntax is we can add a column after the parentheses, and after the column we write the member data. For example, we write months, Then after the member data, we add a parenthesis. This is like we call a constructor. So we add a parenthesis after the member data. And inside the parenthesis is the value to be assigned to months. So for this syntax, month's value will be assigned to months. And we can add multiple initialization. So the next expression assign day value to the member variable day. And for this example, inside the braces is empty because we do nothing inside the braces, and the initialization is done by initialization section. So method 1 and the method 2 are equivalent. And one of the purpose of the constructor is to initialize data, and the other purpose is to validate the data. We can check whether the input data are appropriate. So in the next example, we use the initialization section to assign initial values to member variables, months and the day. And inside the braces, we check whether the two member variables are legal, have legal values. And you can try to compile this example. So I copy the definition of the class day of year, and I also copy the definition of the constructor. And this constructor has two inputs. And this constructor will validate the two inputs. The months should be within the legal range of months is between 1 and 12, while the legal range between day is the legal range of day is between 1 and 31. So if I So for example, if I create an object date1, then when I created this object, then the constructor day of year will be invoked, and the second input day is outside the legal range. So the program outputs illegal day 50. And if your inputs are within the legal range, then the program outputs show nothing. And next we will introduce how to overload constructors. Constructor overloading means a system, a class can have many constructors. For this example, this class has 3 constructors. Function overloading means functions with the same name. So the 3 functions have the same name, day of year. So this is function overloading. And this function is a constructor because the function name is the same as the name of the class. And we know that the inputs of the 3 functions are different. The first constructor has 2 inputs. The second constructor has 1 input, and the third constructor has no inputs. And we recall that a signature consists of function name and the parameter list. So even though the function name is the same, if the parameter list is different, then this signature is considered different. And in this example, the third constructor is called default constructor, and the default constructor has no input arguments. And we can see the definition. The definition of the first constructor. This constructor has 2 inputs. And we use the initialization section to initialize member variables, months and the day. And the second constructor has 1 input. We use this input to initialize months. And the member variable day. We initialize day to be 1, a constant. And for the default constructor, this constructor has no inputs, and we assign constants to the member variables, months and the day. For this example, if we declare date1 like this, then the first constructor will be invoked, because after date1 there are 2 inputs. So first constructor will be invoked. And the second the second object, data2, will invoke the second constructor because because the constructor has only one input, 5. And for the third object, data3, data3 will invoke the default constructor. And because data3 has no inputs, and we need to pay attention to this object, data3. We don't add parentheses compared to data1, data2. For data1 and the data2, if we want to invoke constructors, then we add a parenthesis after the variable name. But for data3, data3 invokes the default constructor, but we don't add a parenthesis after data3. And later I will explain why we cannot add a parenthesis after data3. And for this example, inside the braces, we use this function, testDate, to validate the input month value and the day value. And the definition of testDate is here. So if we want to call the default constructor, default constructor means constructor with no arguments. Then we need to use this syntax. We cannot use this. We cannot add a parenthesis after the object. This is semantic. The syntax is correct. The syntax of this line is correct, but the semantic of this line is incorrect. This line means we declare a function name. The function name is data1, and this function has no inputs because inside the parenthesis is empty. And the return data type is day of year. So for this line means we are declaring a function data1. While the above line is to create an object data1. So the two lines are both syntax. The syntax are both legal, but the semantic is different. The semantic of the second line is not what we want. And we can copy this example. For this example, I use day of year to create an object data3. And for this example, the default constructor is invoked. And next, I add this line. And if you try to compile this program is syntax. The syntax is legal. The syntax for this line is legal because this line declares a function date4, and this function has no inputs. The problem is that when you try to access member variable or member function, and when we use the dot operator and try to access member variable or member function, then this will produce error message because date4 is not an object of day of year. Date4 is a function. This function, the return variable of this function is of data type day of year, but date4 is not an object of day of year, so we cannot use the dot operator to access member function or member variables of day of year because date4 is not an object of day of year. So this line is syntax produce error message. So for this line is the semantic of this line is incorrect, but the syntax of this line is correct. So if you only compile this line, the syntax is legal. So when you see the error message like this, this error message is a request for member test date in date4, which is non-class type day of year. because date4 is not an object of day of year, so we cannot access its member test date. Because date4 is not an object of day of year, so we cannot use the dot operator to access its members. And the next slide introduces how to explicitly call constructors. In example 1, we declare an object holiday, and the default constructor is called because the holiday has when we create an object, one constructor will be called, and in this example, because after holiday, there are no parentheses, so default constructor is called. And then we can use this syntax, day of year. And this syntax this is called explicit constructor call. We directly call the constructor, and this constructor will return one object of day of year, and then this object is assigned to holiday. So for this example, we can create an object date1, and then we can explicitly call the constructor. This is the explicit way to call the constructor. This constructor will return an object of day of year. Then this object is assigned to date1. And note that we cannot directly call the constructor with the dot operator. So we cannot write date1 dot day of year. The syntax is wrong. If we want to explicitly call the constructor, then you don't need the object. So to directly call the constructor, you just write the name of the class. Below is the second example. First, we create an object holiday, and this object, this declaration will invoke the constructor with two inputs. And the next, we explicitly call the constructor. This is the default constructor because the parenthesis inside the parenthesis is empty. So this explicit constructor call will invoke the default constructor, and then the returned object is assigned to holiday. Next is a self-test exercise, and in this exercise, I define a class. The class name is your class, and inside this class, there are two constructors. The first constructor has two inputs, while the second constructor is the default constructor. And below are some statements, and we need to select which statement is legal. The first statement is we use your class to declare an object, declare object 1. And this is legal because this line will invoke the constructor with 2 inputs. And let's see the second statement. So this statement is semantic legal or not for this statement. If you think this statement is semantic legal, then raise your hand. If you think this statement is semantic legal. If you think this statement is semantic illegal, please raise your hand. If you think this statement is semantic illegal. Okay, and this line is semantic illegal. Because this line does not declare an object. This line declares a function. So this line is semantically illegal. Because this line does not declare an object. And in fact, this line declares a function. And the third statement, the third statement declares an object, and the default constructor will be invoked. So the first and the third statements are semantically legal. The second statement is syntax legal, but its semantic is not legal. And next, let's see the following 3 statements. First, we declare 3 objects, and the default constructor will be invoked because after the object name, there are no parentheses. And then we explicitly call the constructor, and this constructor will return one object of your class, and this object is assigned to object 4. So this statement is correct. This statement is legal. The next statement is also legal. The next statement explicitly calls the default constructor. And the last statement is wrong. This statement is not legal because your class is one data type, and we cannot directly assign one data type to another variable. So the last statement is syntax. Its syntax is illegal. So when you try to compile the last line, So when we try to compile this line, the compiler will issue error messages because day of year is a data type. And we can also not use the object to invoke the constructor. This is also syntax incorrect. And the correct way to invoke the default constructor, to explicitly invoke the default constructor, is to like to call a function. So to call the default constructor, you can use to call the default constructor, you can use this way. This is the implicit way to call the default constructor. And if you want to explicitly call the default constructor, then you need to use this syntax. And let's take a break for 10 minutes. The next class, the next hour, we will have a quiz. Hello everyone, and we will have a quiz. And if you need a paper, please raise your hand. The first question is to select the sequence which is not in alphabetical order. And you have 3 minutes for this question. 30 seconds left. And I will close this question. The second question is to select the correct statement. Uh, 30 seconds left. And I will close the second question. The third question is to select the correct option. 30 seconds left. And I will close this question. And if you are done, please forward your paper to the first row. And let's see the answers. The answer is option 2. This sequence is not in alphabetical order. To verify whether this sequence is in alphabetical order, let's see the first letter. The first letters are O, R, B, so we need to check the second letter. The second letter is E, R, O letter E, so we need to check the third letter. E is before N, so bin is before bent. And we need to we need to compare bent with benefit. And the third letter is N, so we need to check the fourth letter. The fourth letter is T and E. And the E should be before T, so benefit should be before bent. So benefit is before bent, and therefore the second sequence is not in alphabetical order. Let's see the second question. We need to select the correct statement. And the correct statement is the second statement. So the second statement is the answer. And the first option is wrong, because the constructor has no return data type, not even void. So the first option is wrong, because the constructor has no return data type. For this example, there is no return data type before the function name, not even void. And the third option is wrong. The member variable can either be public or private. And the fourth option is also wrong. Member function can either be public or private, and the members either member variable or member function declared as private can only be accessed within the class. For an example, month is private, so we cannot access the month variable outside this class. So for this example, compilation is failed because month is private, so we cannot access this member in the main function. But we can access this member within the member function of the class. So we can access month or day inside the member function. This class has three constructors, and 2 member functions. And inside these 5 member functions, we can access the private data. So the second statement is correct. For this question, when will a constructor be executed? And the answer is 3. The time when an object is created. When we define a class, the constructor will not be invoked. And when we use an object, the constructor will not be invoked. For this example, when we define this class, the constructor is not invoked. Or when we use this function, or when we use this object, the constructor is also not invoked. But when we created an object, for this example, the default constructor is invoked. So the answer is option 3. And we know default constructor means a constructor with no inputs. And this constructor is this constructor be auto-generated? The answer is sometimes yes and sometimes no. If no constructors are defined, then the compiler will automatically generate the default constructor. But if you have already defined one constructor, then the compiler will not generate a default constructor. So for this example, if I delete the default constructor, the compiler will not automatically generate the default constructor because I already defined two constructors. So in this case, the compiler will not automatically generate the default constructor. And if I delete all the constructors, and in this case, the compiler will automatically generate the default constructor because in this class there are no constructors. The next slide is about class type member variables. We can use class type members like this one. The member variable date is of data type day of year. Day of year is user-defined data type. And to initialize this member variable, we can use the initialization section like this one. To initialize the member variable, we use the initialization section. After date, we add a parenthesis. This is to invoke a constructor. This invoke the constructor of day of year. And we also, the next slide introduce how to pass parameters. To pass user-defined object, there are two methods. Method one is call by value. And this method copy the input to the local variable date. So this method requires copy, and this can incurs overhead. And for the second method, we use call by reference. And to use call by reference, we add the AND operator. And this method is more memory efficient for class type. Because if the object date is very large, for example, if data is a matrix with 10,000 elements, then this object is very large. And if you use call by value, then you might waste a lot of memory. So the second method is more memory efficient. And we often use the second method to pass class types because the second method is more memory efficient. And in this example, we add the const modifier because we do not modify the data variable within the memory definition, within the function definition. But if your function modifies the variable date, then you cannot add the const modifier. Next, we will enter the second part of this chapter. For the second part of this chapter, we will introduce some tools related to class. We will introduce const, inline, and static. For this example, we define the class of day of year, and this class has one member function, get month, and this member function is very simple. It simply return the member variable month, and we can add a const after. We can add the keyword const after the parentheses in the function declaration and in the function definition. And this means if we add the const keyword, then this means the member function do not change the value of the calling object. For example, one object called date1. Date1 dot get month does not change. If we call this member function get month, we do not change the member variable of the calling object. So we can add a const. For this member function get month, if I try to modify the member variable, then the compiler will issue error message, because when we add the const modifier, then this member function is not allowed to modify the calling object. So we cannot change the member variable month inside the function definition. So when you try to compile this program, the compiler shows error message. Add the const keyword is to protect you. If you don't need to modify the member variable inside this function, then you can add the const keyword. Next, we will introduce the inline keyword. To use this keyword is in front the return data type. So for this member function get month, the return data type is int, and we can add the inline keyword before the returned data type. And this keyword is this keyword is usually used for very short functions. When we use this keyword, the compiler will try to expand this function, for example. And you can use this keyword in ordinary functions, not just member functions. For example, we can define a function test1, and we can make a function call inside the main function. And if you add the inline keyword, then the compiler will try to replace this function with sorry, I modified the definition of this function. Suppose this function has two inputs, x1, y1, and this function returns one integer. And when we call this function test1, and now suppose we add the inline keyword, then the compiler will try to replace this function call with if you add the inline keyword, then the compiler will try to expand this function. So after we expand this function, this is like we declare two local variables, x1 and y1, and then we perform the two statements. So if you add the inline keyword, the compiler will try to expand your function. And this is efficient for very short function. If your function is very long, then it is not proper to expand a very long function. And when we define a member function, for example, when we define the getMonths member function, the function declaration is inside the class, while the while the function definition is outside the class definition. And we can move the function definition into the class definition. So we can combine the function declaration and the function definition into one line. So this line combines function declaration and the function definition. And when we do this, the compiler assumes this function is inline. So when you combine the function declaration and the function definition for a member function, then the compiler will assume this member function is inline. And again, inline function is only used for very short functions. And next, we will introduce the static member variable or static member function. And previously, when we use date of year to declare objects date 1 and the date 2, date 1 has its own members, months and data, and the date 2 has its own members, months and day. And the date 1 dot months is independent of date 2 dot months. But if we want to let all objects of the same class share one variable, then we can use the static member variable. So previously, what we learned, the member variables belongs to objects, and this member variable is not across the class. And for some scenario, we want some variables to be static, and static variables means all objects of the same class can access the same copy, the same variable. And if one object changes the static variable, then all other objects can see the change. And this static member variable is used for tracking. For example, we can track how often a member function is called, or how many objects are created. And let's see one example. For this example, we add one member variable, number objects, and we add the static keyword before this before the declaration of this variable. So this variable is called static. It's called static member data, or static member variable. This variable can be accessed by all objects of the same class. And if we want to initialize this variable, we need to initialize outside the main function. So to initialize the static member, we do not use constructors. We directly assign initial values to the static variables. So this is different. This is different to other member variables. For other member variables, we use constructors to initialize months and day. But to static member variables, we directly assign initial values to the static member variables. And the next slide introduces static member functions. Static member functions means we add the static keyword before the function declaration. So this function, get number objects, is a static function, is a static member function. And for static member functions, we can directly call the static member function without objects. So we can use this line to call the member function get number objects. We don't need any object. Or you can use an object to call this static function. Both two are okay and can be used to call the get number objects function. For this static function, and let's see the definition. The definition of this static member function is we directly return the static member variable. So here we return the static variable number objects. So we can use this function to retrieve the static variable number objects. So for this example, I declare two objects, date1 and date2. And when I create this object, this constructor will be called because the parenthesis has two inputs, so the constructor with two inputs will be called. And in this constructor, we initialize the member variable and the member. We initialize the member variables month and the day. And we also increase the value of the static number objects. The initial value of this static variable is 0. We initialize the value of the static variable as 0. And then after this constructor, the value of the static variable is increased by 1. And next, when we create another object, data2, and the constructor, this constructor is invoked again, and the static variable number objects is increased by 1. So after the two objects are created, the value of the number objects is 2. And we can use the static function. We can use the static function to get the value of the static variable. Because this variable is private. Because this variable is under the private label, so we cannot directly access. We cannot directly access the private member variable. The compilation will be failed because this variable is private. If you place this variable under the public label, then the statement will become legal. And to access the private member, we need to use the member function. So we use this member function, get number objects. We can use the dot operator to call the member function. And this function returns 2 because the value of number objects is 2. And you can also directly call this function. You can call this function without objects. So you don't need the data1 or data2. You can directly call this function. And because this function belongs to the day of year class, so you need to add the scope resolution operator and the class name. And let's take a break for 10 minutes. Hello everyone, and let's continue our class. For this example, we can directly call the static member function without the object. So we don't need date1 or date2. We can directly call the static member function. We can also use date1 to call the member function. So both two methods can be used to call the static member function. But for other non-static member functions, we cannot directly call the member function getMonths. For this class, getMonths is not static because we don't add the static keyword. So getMonths is not static, and we cannot directly call the member function non-static. We cannot directly call the non-static member function. So for this example, you will encounter the compilation error because we need object. The error message says we need object in order to call this member function. So we need either date1 or date2. But for static member functions, we can directly call the static member function without objects. And for static member functions, inside its definition, we can only access or modify static members, and we cannot modify non-static members. For example, inside this definition, we cannot modify non-static members. For example, I try to modify non-static member months. The month is member variable, but it is non-static. And I try to modify non-static members inside static functions. And this is illegal. And when you try to compile, the compiler issue error message. This means we cannot modify the value inside. We cannot modify the non-static member inside a static member function. It is also not legal to directly return the member variable. Non-static, we cannot return or we cannot use any non-static member variable. And we have finished this chapter. We have finished we have finished the introduction of constructors and the following three tools. And next we will return to the pointer chapter. And you can download the CPP file. You can download the demo code from the reference web page. And you can go to the constructors item and find many demo CPP files. And you can try to download this file and run this program to see the outputs. You can do some practice to understand how to use the constructors. Then we will return to the pointer chapter. And in this chapter, we have learned pointers and dynamic arrays. And now we are going to the third part. The third part is about constructors. The third part is about classes. And we will learn big three. Big three includes destructors, copy constructors, and assignment operator. In this slide, I write a test function. In this function, first I declare a string. And for this statement, default constructor is invoked because there is no parenthesis after str1. So for this statement, default constructor is invoked. And next, I assign a C string to str1. And for this statement, the assignment operator for this statement, the assignment operator is invoked. And the next one, I declare another string str2. And after str2 is a parenthesis. So this will call a special constructor. This special constructor is called copy constructor. The input data type is the same as this class. The class of str2 is string, and the input variable is also of data type string. So this kind of constructor is called the copy constructor. And we will introduce this constructor later. In this example, str1 and str2 are local variables to this function. And after this function is finished, constructors of str1 and str2, destructors of str1 and str2 will be called to deconstruct the two objects. So in this part, we will learn the assignment operator, the copy constructor, and the destructor. And the three functions are called the big three, because if you need any one of them, then you need all of them. So the three functions are called the big three. And when we'll use when will we use the big three? When we use the new operator inside the definition of the class, then we need to define the big three. Previously, we don't use the new operator inside the class definition. So previously, we don't need to define the copy constructor, the assignment operator, and the destructor. And in the following example, we will define a class. And inside the class definition, we will use the new operator. And therefore, we need to define the big three. And again, you can download this example. You can download this example from the reference webpage. You can go to the pointers item and find the demo CPP. This CPP file define a class PF array D. After you download the file, and you can run this program. So let's see how to use this data type. Later, I will introduce the definition of this class. First, let's see how to use this data type. We can use this data type to declare an object PFA1. And we can use the member function add element to add one element to this object. So each function call will add one element to PFA1. So we made 5 function calls. So 5 elements will be added to PFA1. And then we call the member function show array to print all its elements. So the five elements are the 5 numbers. And in fact, we implement one dynamic array inside the class definition of P array D. And let's see the definition of this class. First we let's see the constructor. The first one is the default constructor, and the second one is a constructor with one input variable, and this input variable is an integer. The third constructor is the copy constructor, and its input is an object, and this object, the data type of this object is the same as this class. The data type of PFA object is PF array D, which is the same as this class, and this type of constructor is called the copy constructor. And we also have member data. We have a pointer to a double array, and the variable name is A. And we also has two members, capacity and used. And the next, first we define the constructor. We define the default constructor, and we assign capacity to be 50, and we assign used to be 0. And the capacity is the memory size of the array to be allocated. So we will allocate a double array by the new operator, and the memory size is specified by the capacity variable. So for this default constructor, we allocated 50 doubles, and the new will return a double pointer, and we assign this pointer to A, and we assign 0 to used because no element is added. So initially we assume used is 0. And the next one is another constructor. This constructor has one input variable, and the input variable is size, and we will assign size to capacity. So this constructor will allocate the number of size doubles to the array, to the pointer A. So this constructor specify the value of capacity by size, and we also initialize used with 0. And next, we implement the member function add element. This is this function. The input is the element to be added. So the input is a double. And first, we will check whether used is greater than or equal to capacity. If this is true, then this means if this is true, then this means we exceed the capacity. So we print one error message and exit the program. But if used is less than capacity, then we will add element. We will add element to this array and increase the value of used by 1. So we can think of used as the index of the array A. So for this example, when I declare this object, then the default constructor will be called. So this constructor will allocate 50 doubles. Then, so the capacity of this double array is 50, and the used is set to 0. And after this function call, after we call add element, then element is assigned to the left hand side. So element is assigned to A bracket 0 because the initial value of used is 0. Then used is increased by 1. So after this function call, used will become, the value of used is 1. So after we declare the object PFA1, capacity is 50 and the used is 0. And after the first function call of add element, used becomes 1. And after the second add element, used becomes 2. And when the main function is finished, inside this main function, we declare the object PFA1. When this main function is finished, the destructor will be called. And for this destructor, this destructor has the same name as the class. And before the class name, we also have the tilde operator. So the name of a destructor is the tilde operator and the name of the class. And for this destructor, we need to return the memory. Previously, we allocate the memory in the constructor, and when the object is destructed, we need to return the memory. So here we use the delete operator, and we also need to add the bracket because A is a double array. So we need to add the bracket. And the destructor is automatically called when the object is out of scope. And next, let's see the definition of the copy constructor. The input of a copy constructor is an object. The data type of this object is PF array D, which is the same as this class. And then we use PFA.capacity to initialize the member variable capacity. And we use PFA.used to initialize the member variable used. And then we also use the new operator to allocate memory. And after the memory allocation, we use a for loop to copy the value of copy the values of the double array pfa.a to the double array a. So we use this for loop to copy the double array pfa.a to another double array a. So if we compare the copy constructor to the default constructor, we will find the copy constructor performs the copy of elements after the memory allocation. So copy constructor has one parameter of the same type as the class. And next, this slide is this slide lists when will the copy constructor be called. There are three scenarios when the copy constructor will be called. But the three scenario is not guaranteed that a constructor will be called, because this depends on the implementation of the C++ compiler. And next, I will introduce Shallowcopy and deep copy. Previously, what we define is deep copy. And next, I will introduce Shallowcopy. Deep copy means let's see for this example. For this example, first I declare one object pfa1, and the capacity is 2. So the memory size of this array of A is 2, and then I add 2 elements, 5.5 and 6.6. So the double array in pfa1 is like this, and the pfa1.a will point to this memory location. And the next, I declare another object pfa2, and I use the copy constructor. So I provide pfa1 as the initial value of pfa2. And from the previous definition of copy constructor, first we allocate a double array, and then we copy the value of pfa .a to the member variable A. So for this copy constructor, we allocate another memory space, and the capacity is also 2, because we copy the pfa.capacity to capacity, and then we use the new operator to allocate memory. So for this copy constructor, we allocate another double array with 2 elements, and then we perform element-wise copy. We copy each element of PF from PFA1.A to PFA2.A. So for this copy constructor, is called deep copy. Deep copy means we perform element-wise copy of the double array. And another copy is Shallowcopy. And the Shallowcopy does not perform element-wise copy. Shallowcopy only copies the pointer. So Shallowcopy only assign pf.a to the pointer a. And this we can see this from the figure. When we assign pfa.a to the member a, then this means we perform pointer assignment. So pfa1.a and pf2.a will point to the same memory space. So if the copy constructor is Shallowcopy, then pfa1.a and the pfa2.a will point to the same memory space. And we can use one example to illustrate the difference between deep copy and Shallowcopy. First, I declare one object pfa1, and I add 5 elements to pfa1. And then I use the copy constructor to declare another object pfa2. So both pfa1 and pfa2 will have 5 elements, and their values are the same. So if we see the output, so the first line is pfa1, while the second line is pfa2. And now I try to modify the value. I try to modify the element of pfa2. For example, I modify the first element of pfa2 to be 1.2. And let's see the outputs. The pfa1 remains the same, but the first element of pfa2 is changed. Because the copy constructor is deep copy. So the change of pfa2 will not affect pfa1. So this is the definition of the copy constructor. Now suppose I change its implementation. This implementation is deep copy. Now suppose I change this implementation to be Shallowcopy. Shallowcopy means we perform pointer assignment. So I simply assign PFA object data A to the member variable A, and I only modify the definition of the copy constructor. And let's run this program. And let's see that this is the same example. I modify the first element of PFA2. And we see that the first element of PFA1 is also changed. So this means any change to the PFA2 will affect PFA1 because PFA1 and PFA1 data A and the PFA2 data A points to the same memory space. So if you change PFA2 data A, then PFA1 data A is also changed. And this is called Shallowcopy. So this is Shallowcopy. And if you want to perform deep copy, then you need to allocate memory space. So you need to use the new operator to allocate another memory space. So this is like this. You allocate another memory space. And this memory space is different to PFA1 data A. And after this, you need to perform element-wise copy. So you need a for loop to perform element-wise copy, to copy the value of 5.5 and 6.6 to the newly allocated memory. And this is called deep copy. So the copy constructor is either deep copy or shallow copy, and this depends on your application. Some application you might need shallow copy, while some application you might need deep copy. Deep copy needs more memory space, while shallow copy can save memory space. And it depends on your application to decide whether to use shallow copy or deep copy. And if you run this program, you will see one warning, a double free detected. This means because when we finish the main function, the destructors will code. So the destructors of PFA1 and the destructors of PFA2 will be coded. And so the constructor will delete PFA1 data A, and the constructor will also delete PFA2 data A. And for shallow copy, PFA1 data A and the PFA2 data A point to the same memory space. So you double delete the same memory space, and therefore the warning message will show you double delete or double free the same memory space. The next one is about the implementation of the assignment operator. And assignment operator is like a function. To implement one operator is like to define one function. So operator equal is like the name of a function. And the input of this function, is right hand side, and its data type is PF array D, which is the same as this class. And the following is the implementation of this function. And first, we check whether right-hand side dot capacity is equal to capacity. And if the two capacity are not equal, then we will delete the left-hand side, and we will allocate a new memory space, and the size of this newly allocated memory space is equal to the right-hand side capacity. So we assign the right-hand side dot capacity to capacity, and we assign right side dot used to used. Then we also perform element-wise copy. So this implementation is very similar to the copy constructor. If you see the implementation of the copy constructor. One different one thing to know is that this operator returns a variable of data type PFA array. So we need to return a variable of data type PFA array, a PF array D. So we need to return star this. This is a pointer. This is a keyword. And this keyword is a pointer to this class. So this is a pointer to PF array D. And we want to return a variable of data type PF array D. So we need to perform dereference. So we add a star here. Because we use dereference a pointer and to get a variable of data type PF array D. So this is very special, and we haven't seen this before. For this example, we can directly access members inside the member function. So we can access the member stuff inside the member function show stuff. And we can also use the list pointer to retrieve the member. We can use this list is a pointer, and followed in by this operator. This is arrow operator to retrieve the member. And the two methods have the same effect. And the time is up, and let's end our class. And remember that the next week we will have the final exam, and I will post informations on the course website.